Okay, in the previous lecture, we derived the magic equation of calculation of pressure. Very easy, but very useful. And we said that relative pressure at any point equals to density of liquid times depth of point from the free surface. Or mathematically, P equals to gamma times H. So starting from this point, we can imply that pressure varies with depth, is a function of depth. And as we know that gamma is constant, therefore pressure linearly varies because P equals gamma times then the H. Gamma is constant. When pressure increases, H increases, or when pressure or H decreases, pressure will decrease, and this variation is linear. So look at this figure. We have, for example, a profile of water body. The entire depth is capital H, and at this level, pressure could be gamma times H. We have the level. At the bottom level, pressure should be what? Gamma times capital H, because the depth is H. At the top, pressure is, relative pressure is zero. We already talked about it. Therefore, if you connect these three values, this axis shows my pressure axis. Therefore, when the value of pressure is zero, I mean this point. Or when a value equals to gamma H, this is my pressure axis. Therefore, the size of pressure should be gamma H, and at the bottom, gamma H. If you connect these points together, as you see here, this is connection point. There, you will have a linear distribution of pressure at bottom, at liquid. So this is called this pressure distribution. It is linearly distributed at, within the liquid. And if you add just the constant value of atmospheric pressure, assume we said that this is P0, okay? And if you add P0 at any point, for example, I can show like this is P0. From here to here, represent P0. If you add P0 for this point, or this point, or this point, or this point, another linear line with this line can show the absolute pressure, but it is again linearly varies because you just add a constant value. When you add a constant value for a linear function, the function remains linear. Okay, pressure will vary linearly with depth. If fluid is incompressible, it means that when fluid is incompressible, means that gamma remains constant by going in deeper liquid. At the top, if it is compressible, at the lower level of the liquid, we will have more dense, and gamma can increase. But in this course, we assume that, for example, water is incompressible. Therefore, in water, pressure varies linearly. Okay, now we found an equation to calculate point pressure. And from point pressure at each point, at this point, this point, this point, this point, this point, we are able to draw a pressure distribution at the depths of the liquid. But how we can measure it? Always we are not working with papers, and in reality, in practice, we need something to measure the pressure or measure point pressure. To measure point pressure, we usually use manometers. Manometers are a standard technique. Manometer is standard tool, a standard technique for measuring pressure, which involves the use of liquid, some manometry liquid, like, for example, mercury, and a U-shape glass tube. A U-shaped glass tube and a manometric liquid. Then we connect this U-shaped glass tube for any point that we are looking at the pressure at that point. After that, we can measure the pressure. How? With respect the rule that we today learned it. The rule that in any niveau surface or in any horizontal line, pressure should be the same, okay? If the fluid is, and if there is a same liquid. If there is a different liquids could be, but there is the same horizontal level and connected to each other, not different body of liquids. Look, for example, here I have a water tank. Okay, I have a water tank, and I'm interested in finding pressure or measuring pressure at this level, at this point, or this level. If I'm finding at this point or this level, at this point I can say this is the pressure at this level. From calculations, if I know this depths of water, I can say that pressure equals to gamma of water times H. But let's see how we measure it using a manometer. To measure using a manometer, as I told, we connect a manometer using, this is my manometer, okay, a U shape, and it could be a hose, a tube that links the one end of this manometer to the point of interest, which is A. And you know that because of the high pressure of water in the tank, water would like to come to the manometer. It moves to come to the manometer. What will be happen? And manometer and manometric liquid, here is mercury, will moves up. However, after such a motion, finally will stand in a equilibrium. Then it is a condition of hydrostatic, fluid at rest. You can apply force balance or its result, the result is P equals to gamma H. Or another result was that pressure at any horizontal level is constant. We can up those rules, those conclusions can be applied to measure. Let's see how I use it. Okay, this is my manometric system, and it is at equilibrium condition. I found here a interaction point of water with mercury at this level, which I know that both are at the same level. Therefore, pressure at the left at point 1 equals to pressure at the right at point 2. So I have this equation, P1 equals to P2. Is it clear up to here? Is it clear? Because both 1 and 2 are at the same level, pressures are the same. So now I can find pressure at point 1. How I can find at point 1? I know that point 1 is below the A. How much? The distance is Y. Okay, so pressure at point 1 equals to pressure at point B above it, any pressure, whatever is pressure at point B, plus gamma H. Now H is Y. Yeah. Therefore, pressure at point 1 equals to pressure at point B plus gamma H. Which gamma? From here to here, I see that I have water, the green one. Therefore, I wrote gamma of water. Pressure at point 1 equals to pressure at point B plus gamma of water times Y. Here, H equals to Y. How about from right hand, P2 equals to atmospheric pressure, P0, you can neglect also it, plus gamma of this liquid times H of this liquid, gamma of mercury, therefore I wrote gamma C times H, this H, the value of, the height of mercury above point 2. So I can simplify this equation. In that way, instead of PB, I can write PA. Instead of PB, pressure, I can write P of this point, the point of interest. Okay, Malike, why? I can write PA instead of PB.
Same liquid.
Because same level. They are at the same level. Because they are at the same level. At the same level. So PA plus gamma of water times Y equals to P0. All these terms comes at here. And I was interested at the measuring of pressure in A. And now I can say that Pi equals to P0 plus gamma C times H minus gamma S times Y. S means water. Y. So look, P0 is at hand. I know 10 to the power of 5. Either use or neglect it. Gamma of mercury is at hand. 30 point times 10 to the power of 4. Gamma of S, water, 10 to the power of 4 is at hand. H, I can measure it because I brought those manometer there. And H is at hand and Y is at hand because I see the value of Y. I can measure it. I can read it from the manometer. So this is the way that we measure pressure at any point using manometers. Okay, now I will come back to talk about this later, but let's see some other examples. Here, when we are going to talk about manometers, the simplest manometer is this one, which is also called piezometer or piezometer. There is no U shape. It has no U shape. It's only a piezometer. It is only a glass tube with a tank at the bottom. It is called piezometer. And if you have any liquid above this point, you can multiply H of that liquid to its gamma, which gives you to the pressure at this point. And here we have only one liquid, which is called homogeneous fluid. Okay, one liquid. This is a U-shaped manometer, U-tube manometer. And the process of solving problems with U-tube manometer is to finding interactions where two liquids or atmospheric and liquid are separated from each other. Then you can find pressure at one side. You can say that pressure equals to the other side, and then you can transfer this information to the other side, as I did in the previous example.